This is Professor Darrell Seitz, Reasoning with Definitions. Definitions and reasoning. Definitions enable harmonious communication. Definitions enable consistent communication. Definitions are keys to understanding. They're guidelines for reasoning and tools for solving problems. Example, slope of a line. The slope of the line containing the points x1, y1, and x2, y2 is defined as follows. It's a definition. Slope is rise over run, the difference in the y coordinates between the 2 points divided by the difference in the x coordinates. Y is the vertical scale, the rise, x is the horizontal scale called the run. The ratio of the rise over the run. It's a definition. Examining this definition, experimenting with it, and taking different examples, some observations can be made. Slope can be positive, negative, zero, or undefined. Lines with positive slope ascend upwards from left to right. Lines with negative slope descend downwards from left to right. Horizontal lines have a slope of 0. Vertical lines have an undefined slope. Parallel lines have the same slope. Perpendicular lines have slopes that are negative reciprocals of each other. It all comes out of observations from the definition. Application 1, find the slope. What is the slope of the line passing through the 2 points, -2, 5, and 5, -6, shown here in this picture? Use the definition of slope. To solve the problem, your first step, use the definition. Here it is, slope, rise over run. Putting in, substituting the values, -6 minus 5 divided by 5 minus a -2, that's 5 plus 2, -11 over 7. The slope, rise over run, -11 over 7. Negative, it's going descending from left to right. Look at the rise here between these 2 points. There's a distance of 11. And the run, it's a distance of 7. We have 2 here and 5 there. And up here we have 5 and 6. So 11 and 7 involving the rise and the run and a negative slope. Using the definition. Application 2. The slope-intercept form equation. What is the equation of the line with a y-intercept of 0b, shown right here, and a slope of m? Again, use the definition of slope. Slope is rise over run, and for any point, x, y, an arbitrary point on the line, shown here, the slope is y minus b divided by x minus 0. Well, that's y minus b over x. And when you rearrange, multiply both sides by x and then add b, y equals mx plus b, where m is the slope and b is the y-intercept. This is called the slope-intercept form. Slope and intercept, y-intercept form equation for the line. And it came out of using the definition of slope. Application 3, find the slope. What is the slope of the line with the equation y equals 5x plus 3? Use the slope-intercept form that we just derived on the previous slide. That's y equals mx plus b, where m is the slope and b is the y-intercept. So matching the pattern here, we see that m is 5 and b is 3, and the slope is the m, the coefficient of the x, slope is 5. Just a quick match and get your answer without any calculations at all. Application 4, point slope form equation. What is the equation of the line containing the point x1, y1 and having slope m? So this time we're given a point that's not a y-intercept and an arbitrary point here, xy. Again, use the definition of slope. Slope is rise over run, and for any point xy, we can set up m, the slope, is equal to y minus y1 over x minus x1. Rearranging this equation, we get y minus y1 is equal to m times x minus x1. This is called the point slope. The point is x1, y1, slope m, form equation of a line. Application 5, find the equation. What is the equation of a line containing the point -2, 5 and having a slope of -3? -3, if we start from this point, I can go down 3 and over 1, we get to another point on the line. Every time you do that, down 3 over 1, you're going to get another point. That's the rise over run. We use the point slope form that we derived on the previous slide. Here it is, y minus y1 equals m times x minus x1. Putting in the numbers, y minus 5 is equal to -3 times x minus a minus 2. Well, minus a minus 2 is plus 2. And when you distribute here, you get -3x minus 6. If you add 5 to both sides, you'll end up, after rearranging this point slope form, you can get it rearranged into slope intercept form. Y equals -3x minus 1. And right from there, we see that the slope is -3, was what we want, and the y-intercept is -1. Right there, you can see it. Definitions are powerful tools. Make sure that you understand the definitions, you don't skip them, and you learn how to use them for communication and problem solving.